In this video, we're going to cover absolute minimum and maximum on the entire domain. So we're not going to be restricted to a closed interval. So to me, it makes things a little bit more complicated. But let's talk about something real quick. So if you have your function, let's just say we have something like this. This graph would have an absolute maximum here. But because of the fact that it's going to negative infinity, it would have no absolute min. Because it's going to negative infinity. So that's something for us to look out for in this. Sometimes, though, we have those horizontal asymptotes, things like that. You know, so we got to test as it goes out to infinity. What do I mean by that? Is if you have your graph doing something like this as we go out to infinity, because we're talking about the entire domain. So as we go out to infinity, you know, as our graph approaching the highest point at that vertical or at that horizontal asymptote. So just different things to consider. So here's our first one. So we're going to find the absolute maximum of f in this problem. So I'm going to go ahead and go through the product rule. Notice they do have this f has no maximum value. That would be in this case, you know, if the graph just continues to go upward. But we're going to see. Maybe it has that horizontal asymptote and allows us to find that maximum, or maybe it's just going down to negative infinity on both sides and allows us to get that absolute maximum. So let's go ahead and start that derivative. So f prime of x, we're going to have to do product rule. So that's going to be 1 times e to the negative 2x plus x e to the negative 2x times negative 2. So that's e to the negative 2x minus 2x e to the negative 2x. And we're going to go ahead and factor out the e to the negative 2x. So this will never be 0. So really the only thing that we have here is that x equals 1/2. And if you ever forgot to do that, you could just set 1 minus 2x equal to 0, solve for it, and find that value of x. So let's go ahead and test it. This time we're on the entire domain. So we're going to be testing that value of 1/2. So if we plug in a 0, e to the 0 is 1, and that's going to be positive. So positive, positive. By the way, this is always going to be positive here. It's e to that power. You know, there's no exponent you can think of that's going to create a negative value there. You know, like e to the negative 3 would just be 1 over e to the third. It's still a positive number. Let's test the number 2. 1 minus 4, or you can test 1. 1 is greater, right? 1 minus 2 is negative. So we have a positive times a negative is going to be negative. And we're looking for an absolute maximum value. So this could be a maximum. And so let's figure out what that value would be. So f of x equals x e to the negative 2x. So f of 1/2 would be 1/2 e to the negative 2 times 1/2, which is 1/2 e to the negative 1, which is 1 over 2e. So this is one possible value. But we got to just make sure that we don't have this situation where it might be going up to positive infinity. So let's go ahead and do the limit as x goes to infinity and negative infinity. So limit as x goes to infinity. This would technically go on the denominator. I'm going to go ahead and do so. It's a negative exponent, right? Just to double check. Yep. And then we're going to do L'Hopital's on it, because that's infinity over infinity, right? That's that indeterminate form that we learned about recently. And then that's going to be 0 because we're going to have 1 over infinity, right? Same thing with, actually no, limit as x goes to negative infinity. Is actually, I believe, because it's negative infinity, what's going to happen, this is not infinity over infinity. This gives us more of that infinity times infinity or negative infinity times infinity because that negative, putting in a negative number is just going to bring this up to the top. So I believe this one's going to equal negative infinity. And let's just double check that graph real quick. And you can see it does go to negative infinity. And look at this. This has that maximum here, and then it goes off to a horizontal asymptote. So that actually is the answer. This is going to be the answer for our absolute maximum. And so once again, just to talk about this one, what happens is that when you plug in the negative infinity, it just bumps this back up to the top. It's not going to be in the denominator like we had here, because it's going to give it a negative exponent, which will raise it back up to here. But this will be a negative number times a positive is negative, so that's going to go to negative infinity.